Okay, so this is homework number 14. We'll go ahead and get started. Some of this stuff is now introducing some of the tables, finding slope from tables that we kind of introduced to you last week. So, let's just go ahead and jump into this. Number one, each day Grisika is able to save a little bit of money so she can buy someone a gift for their birthday. The amount of money she saves is written in the table below. Write an equation in the form y equals mx plus b to describe the relationship between days and dollars saved. So here is my input and my output. So what I want to do first is for my output, or input and output, I want to label these, okay? So input here, I want to label it with an X. And then output here, I'm going to label that with a Y. Okay, so this is my X, and this is my Y. So remember to write an equation in this form, y equals mx plus b, then I'm going to need to find my slope, which is the m. Okay, so I need to find slope. And I also need to find, make this a little bit bigger, find the slope, and then I need to find the y-intercept. Remember, m stands for slope, the lowercase b stands for y-intercept. So, I go to my table first, and I'm going to find the slope. So what I need to do is find a change in y. So all these values here is what I'm looking at. So, I remember I go to 65 and then 55. I subtract 65 minus 55 because I'm finding the difference. Okay? So the difference between there is 10. Now 55 minus 40. The difference between that is 15. 40 minus 30. Okay, so I see what I'm starting to find is kind of like a pattern, except when I get here, 20 minus 15 is going to be 5. So I kind of go 10, 15, 10, 10, 5, okay? But that's all right, so let's look at my x values here. So I go down to the bottom like again, 11 minus 9, that is a difference of 2. 9 minus 6, that is a difference of 3. 6 minus 4, all I'm doing is just working all the way from the bottom and working my way up. 2, 2, and then this right here is 1. So even though my numbers are different on here and on here, I still can see the pattern. 2, 10, 15, 3, 10, 2, 10, 2, and then 5 and 1. So that's I can associate that with my slope. Now if all these numbers were the same, I would put this number here as my numerator on top of these numbers here, if they were all the same, as my denominator to get my slope. But that's not the case here. My table just kind of skips around and jumps. So all I need to do is put this 10 over this 2. So I'm going to do that underneath here. 10 over 2. I got that from here and here. 10 over 2 reduced is 5 over 1. Now I'm going to take these next two numbers, 15 and 3, and I'm going to do the same thing. 15 over 3. If I reduce that, that reduces down to 5 over 1. So you kind of start seeing the pattern I'm going for and what's going to happen here. Same thing with here, 5 and then the 1. Obviously the 5 over the 1. All of these have a slope of 5. So there is my slope, which is 5. Now the y-intercept, I need to find where x is 0. Now there is no 0 going on here, okay? But I do know that for every one of my inputs, my output changes by change of difference is 5. Okay, difference in y's, difference in values is 5. So if I go from 1 to my next number up here, which would be 0, as my x, if I'm changing by 5s from 15, okay, adding 5 would go to 20, but if I went backwards, subtracting 5 from 15 would give me 10. Okay? So 0 gets paired with 10. So that right there is going to be my y-intercept. So now that I have my slope, which is 5, my y-intercept which is 10, I can write my equation. So I'm going to do that. Y equals 5x plus 10. Okay, so there was a quite a bit of writing on this, okay, but we got to find change in y, change in x to give me my slope, and then work backwards to get to 10 as my y-intercept. All right, number 2. Using the graph below, what's the equation for the line below? So just like what I did on my warm-up today. So let me zoom in. I'm going to put some points, and I'm going to put them in red. So let's zoom in. I'll put a point right here. Make these big dots. Make it a little bit bigger. Put a point there. And then let's go right here. So remember, you can put points anywhere on here, but they have to intersect perfectly within the x's and the y's. I couldn't use this here. Let me zoom in. I couldn't use this point right here on this line because look, it doesn't intersect perfectly. It intersects right here in between. So, so that's what we got going there. So now, from there, I can find my slope. And then also the y-intercept. Those are the two things I need to make my equation. Okay, so from this point to here, remember, I got to see, am I going up or am I going down? I'm going up, so that tells me this is a positive slope. So how many do I go up? 1, 2, 3, 4, 5. This goes up 5. That is my numerator. Then it goes over 1, 2, 3. Going to the right, 3. So my slope is 5 over 3. It doesn't reduce down anymore. If you didn't know that, then you would just put it in your calculator to see if it reduces down anymore. Now my y-intercept. So remember my y-intercept, all I got to do is start here at the top, and then I go down this line until I hit that line right there. Okay? I'm going down, and it crosses right there at the 1. So my y-intercept is a positive 1. You don't have to put the plus, but you can if you wanted to. If it was a negative, remember you put the negative sign. So now I can just write my equation. Y equals 5 over 3x plus 1. Okay. Just like what we did on the warm-up today. There we go. Okay, number 3. In the equation, y equals 1/2 x plus 12, what is the slope, and then what is the y-intercept? So this is very simple. There's not too much thinking about it. I'm going to do this in red. So I'm going to zoom in on the equation here. Now, I'm looking for the slope, which is very simple. It's whatever is in front of the x is the slope. So my slope is 1/2. And then the y-intercept is whatever is attached to after the x, plus 12. If it was a minus, it'd be minus 12. So I include the sign that's with it. Alright? So you can put m equals 1/2. And the lowercase b equals 12. These are your answers. That's all it's asking for. Slope, and then the y-intercept. So that's all you have to put. You don't have to put anything else. If you wrote out slope equals 1/2, that's fine. If you wrote out y-intercept equals 12, that's okay too. Okay, number 4 is another easy one. It's kind of a review question of what we've done like early in the year. We got to classify the square root of 17. So all you got to do is put the square root of 17 in your calculator. The square root of 17, after you put it in, you find out what it would be is 4.12311, and it stops there. But that doesn't mean that this is a terminating decimal. It only stops because it can't go show all the rest of the digits. We know that the square root of 17 is not a perfect square. 16 is, and then the next perfect square after 16 would be 25. So this is 4.12311, and then I'm going to put dot, 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 because it will just keep going on and on and on. So if it keeps going on and on and on, it does not repeat, and it goes on forever, we know that that is a irrational number. It's also a real number because, I mean, all numbers are real numbers. Okay? But it can't be a natural, it can't be a whole number, it can't be an integer, and it can't be rational. So, irrational and a real number. Alright, number 5. Determine the area of the circle below. So we're all getting really good at knowing the formula for area and knowing what to do when you're giving all the way across, which is a diameter. We only need half, which is a radius. Now, if you don't know the formula for area of a circle, you get one of our reference charts that we have in the classrooms, or you can look it up on your phone. Google it, look it up, anything you need to do. So the formula for area of a circle is pi times radius squared. So, like I said, I need the radius, so I only need half of this line. This whole line is 18. I only need half of it, which I did in red right there. So half of 18, you just divide it by 2. The radius is 9. So now that I have that, all I do is just plug it in. So area equals 3.14 times 9 squared. Alright, so I put that in my calculator. 3.14 times 9 squared. We get an area of, after you do that, of course, 254.34. And this is inches, so it's going to be inches squared. Alright, so y'all are doing really good on the circles, finding area.